Hello, everyone. Welcome to our first Jupyter Notebook lecture. These will happen about once a week, and these will be longer videos, and they will follow through a Jupyter Notebook. They will typically walk through top to bottom, working through an analysis. In this case, we're just orienting you to what a Jupyter Notebook is and reviewing Python. We encourage you on these videos to pause them, test things out, write some code on your own, run it, make sure you understand what's going on. I also, if you are unfamiliar with DataHub at this point, I want to remind you that in last week's course announcements, I posted a how-to DataHub video, and I want to encourage you to check that out if you have never used DataHub before. Before we jump into this notebook and working through it, I wanted to make sure now that we've covered GitHub that everybody knows where to find the course materials on GitHub. So it's github.com/cogs108, all caps. Here, there are a number of repos at the top. The overview is where you find the syllabus. Lectures are all the lecture videos from lecture notes from this quarter. So they're building out as their quarter goes on. So this week is O2 data. And you'll be able to find all the PDFs, including the Jupyter Notebook that we're using here. Of course, section materials are in the section FA20, so all of the things used in discussion section will be found there. Tutorials are to help you get through the section material and assignment, so feel free to consult them anytime you're unsure of a concept or want a little more detail. Project information is in the projects repo, and then readings are just optional readings. I also want to let everybody know that if you click on this link at the top of these notes, it's also posted on the homepage on Canvas. This is how to get the most recent set of notes into DataHub directly. So if you click on that and then log into DataHub, you'll use your DataHub account. When you do that, you will see that you get synchronizing Git repository, and this pulls in all of the most recent lecture notes from that lecture's FA20 GitHub repo. So you're able to then in DataHub, click on O2 data and open up the Jupyter notebooks. You'll also see you have access to all of the PDF slides used as well. Note, however, that this only includes the most up-to-date notes. So every time you want to get the most up-to-date notes, you'll have to click on this link. Again, it is available on Canvas. Okay, so with that, we are ready to delve into our first notebook analysis. Here, we're going to be using a Jupyter Notebook. I'll be toggling between it as a Jupyter Notebook and in the slide format, but this is just to visually make sure you're clued into exactly what I'm talking about. So to Jupyter Notebooks, today we're going to be specifying what Markdown is, what code cells are, and touching on what the kernel is. So notebooks are a way to combine code that can run, the output of that code, and text into one connected file. It allows me to share notes with you as well as code, and it gives you a place where you can, in reports, write code right along with text explaining what's going on. I have links to the official documentation in this notebook. If you are new to notebooks, I want you to know that at the top of the menu in Help, there is a user interface tour that you can take to get more comfortable with Jupyter Notebooks and a whole bunch of keyboard shortcuts. I'm only going to tell you about one or two today. So if you want to learn more, that is always available in the Help menu from Jupyter. Okay, so now the next important piece about a Jupyter Notebook is a cell. Each of these specific things that I'm clicking on is a separate cell. These are the main organizational structure of the notebook. You can think of cells as an independent unit. All of these cells so far are markdown cells, which we're going to talk about in just a second. What you can do if you wanted to edit this cell would be double click on it, and then you can click Run. You'll see Run is up at the menu at the top. If I click Run, you then see the formatted text. The other alternative I have is to double click into this cell and then click Shift Enter or Shift Return. This does the exact same thing as pressing the Run button above, but it doesn't involve you using your mouse and then going up and clicking Run. This will become very helpful as you use Jupyter Notebooks. So cells are the organizational unit, and they come in different types for writing different things. For our purposes, mainly text or code. So far, you've seen a whole bunch of text cells. These are markdown cells. The way you know that it is a markdown cell is one when you click on it over here, up here, it says Markdown. If I click on this drop-down menu, you see that we could change it to a code cell. We will get to code cells in just a second. For now, we're gonna leave that as a Markdown cell. So cells can be Markdown text just like this one. Markdown is a way to specify all formatting within the text itself. For example, as you see here, italicized text, if I double click into here to look at the Markdown, you can see that there is a single underscore or a single asterisk surrounding the text that ends up being italicized. For bold text, there's 2 underscores before and after, or 2 asterisks. Now, if I do Shift Enter on the cell again, you can see the results of that formatting. So all Markdown is a way to format text within the text itself completely. There's no clicking and clicking bold or clicking and specifying italicized. It all happens within the text itself. While Markdown is not a critical piece of understanding for this course, it is helpful for when you're writing reports to understand the basics. So the other 2 things I'm going to cover here are headers. You can see that if you want larger text, you would use headers. These are specified with a # or a hashtag with a space. The more hashtags you include, the smaller the text gets, but it's still going to be larger than just plain text. So if I do Shift Return, we can see how that is formatted. The last bit I wanted to mention is that within Markdown cells, lists are also possible. And so you can have unnumbered lists and numbered lists. The way you specify unnumbered lists are with a dash followed by a space, and that will give you bullet points. Or numbered lists where you specify 1 period space and then 2 period space, and this will format into a numbered list. One note, you can have hierarchical structure here. So if I wanted to indent here, add item, and then I could add item, and you can see that we are able to get this bulleted hierarchical structure within our lists. Okay, so review, Markdown is a way to specify all text within a cell. You click on a cell, change it to Markdown up on the menu. And to run a cell to show the formatting, that once you've specified the Markdown formatting, you use Shift Enter. More importantly, I want everybody to get comfortable running code in cells, as this is what you will be doing for most of your assignments. So far we've seen lots of Markdown cells. This here is our first code cell. The way you can tell it's a code cell, one, when you click on it up here, this now cell says code. On the left-hand side here, you'll also notice that it says input. I'm going to clear all my output so we can start with a fresh copy like what you'll see. And what you'll see over here is an empty code cell, so brackets with nothing in it. This means that this cell has not yet been executed. So while there is some code in here, we have not yet run it. We have not yet created the variables A and B. Once I go up to click run or use Shift Return, you'll notice that the code runs and a number shows up here. A number indicates that this was the first cell to run. When I get to the next one, where I've now created the variables A and B above, storing the values 1 and 2 in it respectively, I can now create a new variable C, where I do A minus C. And I can print the output of that cell. So C stores the value of A1 minus 2, which is -1. When I print that, I can see the output here right within the Jupyter Notebook. Notice that 1 remains as it is, 2 being the next one. If I were to run this cell again, Shift Return, notice that that increments by 1. If you execute a cell in a Jupyter Notebook with just a variable name, it will also get printed. So notice I've print B, and then C is the last thing here without print. It will print whatever the last variable is. However, if I get rid of the print around B, it's only going to return C here. It only prints the last variable in the cell. So it's only going to print the output of C. If you want to print something beforehand, you have to specify print explicitly. All right, so as a reminder here, the number in the square brackets to the left of the cell shows which cells have been run and in which order. If you ever wind up with an asterisk in between these square brackets, that means the cell is currently running. That can happen when you have code that takes a little while to compute, which will happen in some of your assignments, or if you have an infinite loop. If you have an infinite loop and realize it, you can use stop here, which will stop running the code there. If that fails, you can always restart your kernel, which will clear out any of the variables currently stored in this notebook. One note is you do not need to run the cells in order. This is flexible, allows for flexibility in testing and developing, but can sometimes confuse people in that you can create a variable earlier on in a notebook if the cell has been run later. It's best practice to have the cells run in order. So when you have your projects, everything should run from top to bottom, and the same will be applicable in your assignments. Okay, so that's the general rundown of a notebook. It allows you to run code, write code, execute it, see its output, and include text. A code cell will always have the input to the left with the square brackets. Once a cell has run and executed, a number will show up here. Okay, now for accessing documentation, Jupyter has helpful shortcuts. If you add a question mark after, say, a function in the documentation, it will pull up the documentation for that at the bottom. So you can learn that ABS is the absolute value of the argument, and that is a built-in function. Jupyter Notebooks also have autocomplete. So tab completion capabilities exist. So for example, if you are looking to see what is available that is RA, you can see that Python has raise and range. In the second cell, when I put my cursor after it and then hit tab, it will, in this case, because there's only one option, fill in the only possible option. So again, what I did here was put my cursor after here and hit tab, and then I can select which of the ones that I want to use. This works well for variables that you create, and it can save you a lot of time from typing very long variable names. You just type in the first few letters, hit tab, and then select the variable name you want. As for a web browser, notice that Jupyter is currently open in Chrome for me. It displays in a web browser, but in this case, I'm using my computer. Jupyter Notebooks just take advantage of the fact that web browsers display things nicely, but it's not actually running on the internet here. If you open it on DataHub, it will be opening it on UCSD's computers via DataHub. So in that case, you will be using the internet to connect to UCSD. Whenever you see localhost, that means it's open on your computer. If you are on DataHub, it will say DataHub. The local connection here is to the kernel. When we talk about the kernel is the thing that executes your code. It is what connects the notebook, what you're seeing, with the part of your computer that is actually running the code. Your kernel also stores your namespace. And your namespace is all of the variables and code that you've declared or executed. So earlier we created A and B and C. Those are all stored in the namespace. It can be useful to clear and relaunch the kernel, especially if you say have an infinite loop working. This is all from the kernel menu here. Restarting and clear output. Notice this doesn't clear your code, it just clears the code that you've executed. So restart your kernel, clear all of your variables out of the namespace, but all of the code you typed remains. So this will erase any variables stored in memory, so you'll have to rerun the code to create them again. To learn more about Jupyter Notebooks, there are tips and tricks linked to and more information on exactly how these are working. Okay, throughout this quarter, you will get very comfortable working in notebooks if you are not already. So make sure you understand the basics of what were discussed here before we jump into the Python review. So this is a good chance in the video to pause it if you want to play around with anything that I just described to make sure you understand what we said before we move on. Okay, so we are going to do the world's quickest Python review here. We're going to talk briefly about variable assignment and types, operators, conditionals, loops, and functions in Python. This is, 5 to 6 weeks in COGS 18, Introduction to Python, and we're doing it here in basically half a lecture. It is intended to be a review. So if you are stuck, spend some time with each of this, pause the video a whole bunch, spend the time now to make sure you understand what's going on. All right, I am, now that we are a little bit more comfortable with the Jupyter Notebook format, going to switch to the slide view so that we can all be focusing on the same bit. Okay, so when it comes to variable assignment, in Python, variables are assigned with a general syntax, variable name equals, and then the value you want that variable to take. For example, my variable equals 1. My variable here is the variable,
and I can define another variable as well. So when I run this code, you can see that it's now been run by hitting Shift Run. My underscore variable stores the value 1. Other underscore var stores the string. Variables are cool. If you're coming from Java world, you'll see that Python is dynamically typed. We do not have to specify the type of variable. Python infers it from the input. Once you've created a variable, it is stored in your namespace. So if I execute this code, I can get the output of my underscore variable and see the output right here. Now, if you have been away from coding for a little bit, a reminder that code variables are not the same as math variables. In mathematics, the equal sign refers to equality. It states that the thing on the left is equal to the thing on the right. In coding, the equal sign refers to assignment. So in math, it makes a lot of sense to say y equals 10x plus 2, and you can do the algebraic explanation of solving for x. However, if you were in math to say that x equals x plus 1, this doesn't make any sense mathematically. Here in programming, it makes total sense. If you have a value stored in x and you want to increment it by 1 and then assign that back to the variable x, this is a totally reasonable thing to do. So just as a reminder, here we're assigning information, whereas in math, it's checking equality. Generally, it's helpful if you're new to Python to know that there are 33 words that are reserved. You cannot use any of these for variable names. So if you try to assign a variable called true, Python's going to give you a keyword error. All right, so the world's quickest review through variable assignment. Names of the variables are always on the left of the equal sign. Values you want them to take are on the right. Names are case sensitive. So capital T, capital R, capital U, capital E is going to be different than lowercase t, r, u, e. Variables cannot start with numbers or special characters. And Python doesn't care what you name your variables. Earlier you saw I called it A, B, and C. Aside from those 33 reserved words, Python doesn't care. Humans do care. Pick names for your variables that describe the data or the value that they store and makes your code much more readable. Okay, so now for a tour through the different common variable types in Python. We have strings, integers and floats, booleans, none-type variables, lists and tuples, and dictionaries that we're going to walk through quickly now. So each variable in Python has a type. It refers to the kind of variable that it is and how the computer stores that information. I said this before, but Python is dynamically typed. The variable type is determined at assignment. I have a definition of the common variable types here, where when you get down to collections like lists and tuples and dictionaries, these are going to store a collection of items. If you want to store a string or an integer or a float, something with a decimal point, you would use the types of variables up here. Booleans store true or false, and none type is a special type in Python that stores the concept of nothingness. So we saw this before, where you can store a value in a variable, and you can always ask Python what type of variable it is using type. Now you'll notice in Python there is some helpful, in Jupyter there are some helpful colorings. So here, 1, demonstrate that this is an integer, type, demonstrate that this is a function. So you can use the type function, give it the input variable name, and it will let you know that variable underscore name is an integer. When you want to start working with and operating over variables in your code, you need to understand the basic operator types. So we've already covered the assignment operator. We're going to go briefly through math, logical, and comparison operators. So equals for assignment. There are additional assignment operators in Python, but this is the one we use all the time, so we're going to stick to that for now. Math operators are what you use for carrying out mathematical operations. You can see addition, subtraction, multiplication, and division here. Double asterisk is used for exponentiation. The modulus is used to determine the remainder between two numbers after division. Double slash is for floor division, also known as integer division, and these follow the rules for the order of operations. So PEMDAS, or please excuse my dear Aunt Sally, parentheses, exponentiation, multiplication and division, and then addition and subtraction. After the math operators, we have comparison operators, which are incredibly important. These operators return Booleans. If you want to test for equality in Python, you use the double equal sign, just like in many other programming languages. If you want to check that values are not equal, you use the exclamation point or the bang equal sign. Less than and greater than, and less than and equal than, and greater than and equal than use the same ideas used in mathematics. Logical or Boolean operators, these use Boolean logic, and these are and, or not. These are the three operators, and these return Booleans. And will return true if both conditions are true, both sides of the operation, or will return true if at least one is true and not negates it, so it's true only when something is false. The last bit we want to review here are conditionals. Conditionals use if, elif, and else in Python, and we're going to see the syntax for this in just a second. So if checks a condition using the if statement and then only executes the set of code following it if the condition following the if statement evaluates as true. After an if statement, you can have any number of elifs, this stands for else if, to check other conditions. And then else, this is the catch-all at the end. After an if, you can use an else, and this, whatever follows the else, will run if the conditions above have not yet run. So for example, the general syntax for a conditional in Python is here. We can have condition 1 store the Boolean false, and condition 2 store the Boolean true. If condition 1, meaning if this is true, print this code executes only if condition 1 evaluates as true. We then have an elif statement. Notice that there is a condition that follows both the if, the elif, and at the end of this, there's always a colon. Else has no condition because this is the catch-all at the end, but there's still a colon. And Python cares about white space. So you need to have indentation for each of the code blocks within your conditionals. So if we run this code block, we can see this code executes if condition 1 did not evaluate as true, which when we look above, that is the case. It is currently false, but condition 2 does. Great, that one is true. If I go and edit this code so that condition 1 is true, we see that condition 1 is now going to be true, so it should print this code executes if condition 1 evaluates as true. When we rerun it under those conditions, that is in fact the case. Now, conditionals and operators are really helpful for controlling the flow of your code. So for example here, the language is set to the string Python. The conditionals here say if the language is equal to Python or the language is equal to R, giving it two options here, print yay. I say if the language is Perl, print oh no, and otherwise get yourself a programming language. So we can see that we have the if, the elif, and the else, but we also have operators here that operate within it. So when the language is Python, it will print yay. If this is changed to Perl, we would get oh no. And if we change this to anything else, it will go down to the else because the if and the elif are not true, and it will print get yourself a programming language. Okay, again, whirlwind tour through intro programming. A loop is a procedure to repeat a piece of code. We have while loops and for loops that you may have to use throughout your experience in this class. While loops will repeat a piece of code while some condition is still met. A for loop will repeat code for every element in a sequence. The general structure will look very similar to an if statement where you have a while and a condition followed by a colon. On the next line, you'll have an indentation and all of the information within the while loop will be indented. So while the condition is true, execute the code contents, repeat until the condition is no longer true. For loops, on the other hand, follow the general structure for item in iterable variable. This means that item will represent whatever place you are in the iterable until you get to the end, and anything you want to happen within the loop will be indented in the code block. So for each item in iterable variable, execute the code contents, repeat until you reach the last item in iterable variable. Functions will be critically important, especially in your projects. You will be required to write them in a number of assignments, and it is a reusable piece of code that performs operations on a specified set of variables and returns the result. The general syntax for a Python function is here. You have the definition giving the function a name here, which is print value, and it takes some input here. The input parameter is num. Again, opens this code block with a colon, and then all of the function's contents are indented. So here we define print value, and all it does is print the input value. It's a very basic function. We can, of course, add additional functionality. Where here we have a function called even_odd. It takes a value as input, and it says if the value modulo 2, meaning if the remainder after you divide by 2 is equal to the value 0, out will be stored, will store the string even. If the input value modulo 2, meaning the remainder after dividing by 2, is anything other than 0, the variable out will store the word odd. To return information from a function, you need a return function, and this is going to return whatever is stored in out. So when I run this cell, we'll see the number pop up here. This will define the function, but it doesn't execute the function until we call the function's name and give an input. So here, the input is -1, and we can see that this will return the string odd. If I make this a even value, it will return even. Okay, so I know that was a whirlwind tour of Jupyter Notebooks and Python code. I encourage you to pause, return, go back, test things out, make sure you understand both how Jupyter Notebooks work and the basics of Python. Your first assignment will be and is intended to be a review of Python. It is not meant to have all been taught in this lecture, but the idea is you should be able to work through it after this and with your prior programming experience.